Hey, happy November and welcome to Explore Classroom. My name is Jennifer Bergen and I am so glad that you are joining us today. At National Geographic, we know the power of exploration, wonder, and storytelling can change the world. And this Explore Classroom YouTube show connects students from all around the world with our National Geographic explorers for short lessons and time for your questions. Today, our explorer is Melanie Kirby. Melanie is a member of the Tortugas Pueblo from southern New Mexico. She is committed to working for bees and their beekeepers to better understand the science and the art all around beekeeping. Melanie loves to storytell about what she learns from bee history and science, which is called apiculture. And she shares what she learns with people through her writing. Today, she's going to share about apiculture with you. But before we get into today's lesson, let's welcome our registered friends joining us from all around the globe. Today, the registered students in our audience represent 27 different United States and 5 different countries. We've got Ayla Bees, Albion Heights, Albuquerque PSD, as Zahra Islamic Academy, Bells Elementary, Brownsville ISD, Cannon Elementary, E-Academy Virtual, Edgewood PS, Fairbanks Best, Franklin Elementary, Hoffman Boston, Isle Ohot Rural School, John E. White Elementary, Johnson Elementary, Jonas E. Salk Elementary, King George, Kitson Central, LaWard's class, Little Harbor, Lauren Park, Mrs. Victoria's class at Manteca, Mindham County Day, Miami Shores Elementary, Panaga, St. Luke's School, Samuel W. Tucker Elementary, Sheikh Hillel Elementary School, Community School, Sona, Sonnet and Sawyer, Temple Elementary, the Barn House, the Wagners, and Wolf Ridge. We are thrilled to have you and more guests here today. And with that, let's get this Explorer Classroom started. It's time to turn it over to Melanie to share all about bees. Take it away, Melanie.
Boo! I know it's the day after Halloween, but I just wanted to still wear a costume. Plus, I got this snazzy bee scarf. Actually, it's upside down, huh? There's bees of all different colors on here, just like us. And so we're going to talk about that today. So happy to join you all. And yeah, I should warn you, once I start talking about bees, it's kind of hard to get me to stop talking about bees, but I will do my best to keep us on time. And I really look forward to hearing your questions and getting to know you a little bit better. So I'm going to share my screen. And let's see here. I will share with you that I had hoped to actually beam in from what's called an apiary, which is where I keep my bees. However, it's a little bit cold here. And so I wasn't able to get into the bees today because I'm in the Southern Rockies, which is at the very southern part of the Rocky Mountains. I'm in northern New Mexico in Santa Fe, which is the capital of our state. And we've already had snow. We had snow a few weeks ago. It did melt, but all the leaves are off the trees. And so it's getting pretty cold. And so I'll talk to you a little bit later about the bees' life cycle, but that actually, when the weather turns cold, the bees don't necessarily want to be disturbed. So I will start my slideshow here. So this is called All About Bees with the Nectar Nomad, me, Melanie Kirby. I like to call myself a nectar nomad because I like nectar. Of course, I love honey, but I also really like to travel, and nomads mean that they travel or they move around. And so I like to visit bees and their beekeepers all over the world, which is really a lot of fun and very interesting. I learned something new every day. So I'm going to share with you this little video that's about me and how I got started and what inspires me. I've traveled many a bumpy road in the darkest of nights, serving as a chauffeur to beings of sweet starlight. I migrate with them, like a shepherd, roaming with my flock of winged midwives, as a fellow follower of the bloom, a self-proclaimed nectar nomad. I was introduced to this artistic science of beekeeping 2 decades ago as a U.S. Peace Corps volunteer collaborating with peasant farmers in South America. The bees captivated my curious mind, and working in an outdoor office made of fresh air, flowers, and freedom enticed my soul. My nomadic journey as an apiculturist has taken me far from where I could ever have imagined, having come from a humble home in Pueblo Indian country in New Mexico. My heritage is a mosaic of cellular memories influenced by my Native American ancestors, who instilled in me a profound reverence for place and purpose, and to pursue acts of community service. So I chose to become a bee farmer, as I wanted to continue to learn from Mother Nature and Father Time. As a farmer, I share beekeepers' voices of concern and need for adaptation and innovation to fulfill our dedication for local to global food production. Sharing their challenges, I became encouraged to return to academia to help quantify their observations and advocate for pollinator conservation. Now, as a researcher, my quest to better understand the relationship between cultures, food systems, and stewardship is at the forefront of my thoughts. Honeybees are like some of us and our ancestors, immigrants to this country. They have adapted and become the backbone of agriculture. There are distinct ecotypes or subspecies of honeybees like races in humans, and these ecotypes carry genetic histories like seeds which contain their very existence and memories of creation. For within each one, they have the power to nurture and adapt, and the magnificence to create life, food, and medicine for the world. One of the things I most enjoy about beekeeping is that it bridges cultures and goes beyond borders. It connects us to our origins as fellow beings of light, as a part of this land, not separate from it. This magnificence is alluring and inspires me to find and connect with bees and their keepers around the globe. I invite you all to accompany me on my nectar nomad storytelling journey as I chase the bloom, encounter cultures, and follow the liquid starlight known as honey from flora to flavor to feast. Awesome. So that's a little bit about me, and I like to play it to the end because I list my mom. My mom is the one who played the music, the flute music in the back. And so we call her a wind rider because she knows how to play music through a flute, right? Which you blow through. And so anyways, yeah, that's a little bit about my background and my history, and how it really kind of plays into what I do now. And so I think it's really important for all of us to recognize not only where we come from, but where our ancestors come from. This month, November, is actually National Native American Heritage Appreciation Month. So it's really cool to learn about all the different Native Americans that are here across what we call Turtle Island, or the USA, this continent, North America, which also includes Canada and Mexico and parts of Central America. And so interestingly, there's over 500 different kinds of tribal communities. And mine is just one of those tribal communities, right? So wherever you live, there's going to be indigenous peoples. And most likely you are somewhere in your past or through your ancestors related to them. And just like bees, they can be found all over the world, right? And bees can be found almost in all parts of the world. They can't live where there's a lot of snow, but they can live where there is flowers, or there are flowers, sorry. I'm stumbling on my words. So all over the globe, we have observed close to over 20,000 different kinds of bees. Okay. And you can see from this picture here that they're all different looking, right? Some are big, some are little, some are metallic-y looking, some are fuzzy looking, but these are all bees. And they live in different places. So some live in cold places and some live in warm places. Now, if you lived in a cold place, you'd probably need a lot of fuzz, right, in order to keep warm. And so there's actually some research that has found that some of these Arctic bumblebees, when they move their flight muscles, their wings, they can actually, within 5 minutes, turn their body temperature up 30 degrees Fahrenheit. So they can keep warm, and they can keep their nest warm even when it's super, super cold. And then there's also bees that live in warmer places and tropical places. These are orchid bees that you can find down in Australia. And they look very different, right? They're blue. Some bees actually live alone, and they're considered solitary bees, like this little bee here who lives inside a hollow reed. So sometimes if you're out on a little hike or a walk, and it's fall or winter even, and there's leftover plant stalks from flowers or from other plants from the season before, people tend to want to kind of cut those and get them out of the way, but it actually provides a lot of habitat for some of these solitary bees and pollinators. And others are called social species, and they live together in a colony or in a hive. Now, these are bumblebees, and they're very fuzzy. They actually have a queen who will lay all these eggs, and then the rest are her daughters, and they help to take care of the hive. And I'm going to talk to you a little bit more about a particular social species of bees called honeybees. Bees actually help to pollinate so many different kinds of food. And the picture on the left shows pollen grains. This is a really close-up picture. They call this macro photography because it means really, really up close. And you can see all those pollen grains. So sometimes when we see pollen, it just looks kind of like powder, right? But if you look really close, pollen actually has a lot of different shapes, and it helps to actually create all these different fruits and vegetables that we eat. So do you recognize some of these in this picture over here? I see some of my favorites. I love avocados. I also really like citrus. I like nectarines. I like peach. Shoot, I like everything on here. Nuts. How many of you had Halloween candy last night? Even bees help to pollinate chocolate or cocoa plants that make chocolate, cacao. And for your parents who might like coffee, bees help to pollinate coffee plants too that help make coffee. So what is pollination? And some of you may have heard of this already. And for others, it might be kind of a new thing to learn about, but I'll talk about it briefly. So pollination is when the pollen grains, which a plant produces or a flower produces, get moved to another part of the flower in order to help fertilize the inside of the plant where the eggs are, or the seeds are, right, within the ovary of the plant. And that's what ends up creating a fruit. And then the fruit or the vegetable can then grow more seeds, right? And then these seeds we can save and we can plant, and then we can continue the cycle. So I like to consider this a type of dance, a seasonal dance that happens usually every spring and summer when it's warm enough. And the pollinators and the flowers communicate with each other in lots of different ways. The flowers know that, we tend to think that flowers don't think, right? But they must somehow know how to make themselves look pretty and how to smell good. And so they're in competition with one another. So different flowers will create different perfumes, and their nectars will be sweeter or less sweeter, and their pollens will be different too. And so the pollens and the nectars actually are what entice or encourage the pollinators to come and visit. And the pollinators, when they're coming to visit, they're actually collecting for a specific reason, which I'm going to answer in just a minute. But as they're collecting pollen, they're actually moving it to different parts of the flower, and that helps the flower to be pollinated, and then they're able to create their seeds and their fruit, right? So this diagram shows that the pollinator receives the pollen from the stamen of the first flower, which are these big, long, sort of fluffy things here. They look like little microphones, right? And then they collect it onto their legs. They have what's called a corbicula or a scopa, which is underneath on their abdomen. And it's just a lot of hairs that help to collect the pollen, and they actually will move it down. I have a little video that'll show you that in a minute. And then when they go visit another flower, some of that pollen will drop off into the stigma, which is at the top, and fall down. And then it helps to actually pollinate the ovules in there. And ovules means eggs, but that's what are going to turn into the seeds. So why do bees pollinate? Really good question. So the bees, I mean, they're not necessarily doing that job specifically just to help the flower, right? They're wondering, what are they getting out of it? And so part of it is it's a relationship. It's this dance, like I called it, where they actually help the flower to reproduce, and the flowers actually help them to reproduce, to help the bees to reproduce too, because they're sharing their pollens and their nectars with the bees, which then the bees can use as food. So the picture on the left here, I love this picture on the left. I took this one a few years ago, and you can see all these different colors here in the honeycomb cells. Those are all different kinds of pollens. And so each plant produces a very unique kind of pollen, and some of them have really high nutritional values. So all pollen has a lot of enzymes and vitamins and minerals, and the bees need that. It serves as their protein. And so they bring it back and they collect it. And it's nice to see a bunch of different colors in the hive, because then that means it's almost like Skittles, right? I keep talking about Halloween candy, but it's almost like tasting the colors of the rainbow, right? The honeybees then have all these different kinds of pollens, and collectively it makes a more nutritious food for them. And they use that pollen when they eat it as their protein. They use it to then convert into royal jelly. And on the picture on the right, you can see some of this royal jelly. So if you see these little half moons that are kind of floating in there, those are baby bee larvae. And so the ones that look like a little rice, a grain of rice on end, really tiny, that's an egg. So the baby bees actually start off as an egg, and then they hatch after a few days, and then they turn into a larvae. And when they're a larva, they're just like a little tiny grub or a little caterpillar, right, inside the honeycomb. And they can't really go anywhere to eat. So the sister bees, these worker bees right here on top of the comb, will actually eat the pollen, convert it into royal jelly. They have special glands in their cheeks, and they will convert it into royal jelly, and then they'll feed the baby larvae. And so that's this glistening kind of creamy stuff you see in here. And it's kind of like mother's milk. It's kind of like when you were a baby and you had to drink a lot of milk, remember? And the milk was really nutritious, right? So that's what royal jelly is for the bees. It's like baby milk. And basically, it gives them a lot of vitamins, a lot of amino acids, and different nutritional molecules that they need to then grow. And so their sisters will feed them for almost about a week, and then they'll cap them over with a thin piece of wax, and the larvae will begin to metamorphosize, and they turn into a pupa, right? So just like butterflies, they undergo metamorphosis. So here's a really cool video that Nat Geo put out. So this is how our baby bees made, and we can watch them hatch before our eyes. So let's check this out. Oh, it's got a commercial. I apologize. I didn't realize it was coming through the commercial.
Here is a bee egg as it hatches into a larva. Those newly hatched larvae swim around their cells, feeding on a liquid food that nurse bees secrete for them. Then their head and their legs start to differentiate as they transform into pupae. Here's that same pupation process seen from above with varroa mites running around in the cells. Next, the tissue reorganizes in their body and the pigment slowly develops in their eyes. In the last step, their skin shrivels up and they sprout hair.
and then they're born. So yeah, apologies for that. I should have embedded it a little bit different. But yeah, when they emerge out, then they actually have different jobs that they do. But it takes a while. So I wanted to talk to you before I show you this next video. I want to talk to you a little bit about when the baby bees are formed. So I mentioned they're an egg for 3 days, and then they hatch, which we saw in the video, right? Then they turn into a larva, and then they're a larva for about a week, and then they get capped over and they do that pupation. And then the pupation process takes a while. If they're going to be a worker bee, then it'll actually take, from start to finish, it takes about 21 days for them to be born. And if they're going to be a male bee or a drone, then it takes them 24 days. And if they're going to be a queen bee, it only takes about 15 and a half, 16 days for them to form. And so each one of them has a special role, and they learn from each other and teach each other how to do these different roles and these different jobs. And so that's why they're considered social creatures, because they live not only together, but they work together to keep their whole hive family functioning. So we'll show you this little video, and hopefully there's not too many commercials with that.
I'll be your family.
Of course. And I should have, I tried to embed this, but it said it was too long. So then I changed it to this.
That's a big red
This is what happened. Now we know about Clifford the Red
honeybee is one of the most collaborative insects in the world. Each hive is comprised of thousands of bees working together in order to build and sustain a colony. Within the colony, each bee has a specific role to play, a job, if you will. These are jobs like foraging for food, tending to young larvae, and building a honeycomb. But with a brain about the size of a sesame seed, it begs the question, how do bees know what specific job they need to do in order to keep balance in the hive? The answer is written into the genetic makeup of each bee. And it starts with the queen bee, who has the unique ability to designate the sex of her children, which plays a pivotal role in their future. If the queen wants to lay a female egg, she will fertilize the egg by releasing spermatozoa that is stored in the spermatheca, which sits behind her ovaries. The spermatheca is filled during her first week of life, when she mates with up to 20 drones, or male bees. If the queen wants to lay a male egg, she will not release any spermatozoa as the egg leaves the ovaries. And drones have a singular job. That job is to mate with queens from other colonies to propagate the species. When they're not trying to mate, they eat leisurely from the honey reserves and wait for a queen to go on her nuptial flight. Female bees, or worker bees, do literally everything else. They keep the cells clean, care for the larvae, build cells, tend to the queen, store honey, forage, pollinate, guard the nest, and even feed male bees honey if they're begging for it. Each bee knows what to do because their hormones activate the part of their genetic makeup that tells them what jobs they have to tackle and when they have to tackle them. They go through 4 phases of jobs before dying. In phase 1, bees go to work immediately after they emerge from metamorphosis, about 3 weeks after they're born. They begin cleaning the cells from which they emerged. After about 3 days, their hormones shift them into nurse bee mode. In this job, they feed the young brood that succeeds them. This lasts for about a week. Then phase 3 kicks in, and the workers become general handymen, moving farther away from the center of the hive and doing things like building honeycomb, storing food, and guarding the nest entrances. This lasts about a week. The final phase is the most dangerous. It's the foraging phase, where workers leave the nest to find pollen to bring home and feed the colony. This phase starts around day 41 and lasts until about day 50. After a short life of constant work, most workers will leave the nest as death approaches. The corpses of those that die inside the hive are carried out by undertaker bees. It's a thankless life for the worker bee, but this collaboration and process has made them one of the most successful superorganisms in nature.
Yeah. So you can tell they work really hard, right? And in the summer, or in the spring and summer, when things are warming up and there's lots of flowers, the worker bees will live about 4 to 6 weeks. And in the winter, because there's not any flowers, they can actually live several months. The queen bee, on the other hand, she can live for several years. And the drones, or the male bees, they can live for several months too. And a lot of that just has to do with their diet and how they work. So the queen bee is the one that gets fed a lot of royal jelly, so that then she can actually live longer because it's so nutritious, right? So royal jelly is her main diet. She will eat some honey, especially when she goes on what they call her nuptial flights to go and mate, because she'll need a lot of energy. And the honey actually serves as the carbohydrate. So I talked about pollen being the protein and honey being the carbohydrate. And so together those make like a complete meal for them. And interestingly, not all honeys taste the same either, right? So when they're, and just like the pollens that are different colors, the honeys can be different colors too. So they can collect honey from all these different plants. And then as it gets mixed together, these different nectars get mixed together. They also will bring it back home. They carry it in what's called a honey crop. So when they're visiting the flowers, they're sucking up the nectar that actually goes into their honey crop. Some people like to say honey is bee barf, but that's not true. It's not that gross. They have their regular stomach, and then they have a little separate pouch that just holds the honey, just holds the nectar actually. And then when they fly back home, they're able to pump back out that nectar from their honey stomach, and they pass it from sister to sister. This is called the bee kiss. It's also called trophallaxis, and they pass it from sister to sister, and it gets mixed with enzymes in their mouth. And then they actually will store it away in the honeycomb cells. And nectar is really watery, so they don't want it to spill and they don't want it to ferment, because if it ferments, it'll turn into like wine, right? And bees don't want to drink wine. We'll save that for adult people, right? So what they'll do is they'll fan it, and they'll work together to dehydrate it by fanning it. And then they actually make that nectar turn into honey. And it takes a while, but then once it's at the right consistency, which is usually less than 17% water, and the rest is mostly then plant sugars, then they're able to cap it over, and then it is good indefinitely, meaning it has an infinite shelf life. Honey, pure raw honey, never goes bad. And they've even found honey in the Egyptian tombs that is still edible today, and it's over 3,000 years old. And I really want to just have one little lick of that honey. Could you imagine tasting what 3,000-year-old nectar tasted like? It's probably delicious, right? Honey is so special because it's mostly plant sugars. It actually does a lot of different beneficial things. It can be used as a medicine. So because there's so many sugars in it, bacteria can't grow in it. So people use it, various cultures use it on cuts and on wounds and on different ailments. They even use it for horse care. Like if a horse gets a wound, they even use it on sea turtles. Like if a sea turtle or say a manatee gets kind of cut by a boat propeller or something, they can't really take them out of the water to let it heal, but they can put some honey on it, and honey will keep it moist, but also keep bacteria out. So honey is pretty special. I have this other video that's of me actually, because I was hoping I could take you guys into the bee yard with me, but since it's cold here, I wasn't able to. So I have this video that we actually filmed less than a month ago. This is just a couple weeks old, when we were getting our bees ready for, we were harvesting honey and then getting them ready to prepare them for winter. So this is a video that one of my students took, and then I added some music to it.
Especially right here in these low areas where the creek beds.
Quickly, they have these things called fumes, which is just like the lid that I took to cure it properly and freshen it. We have one of these at the farm. It's like a table. It's out of like just the frame, but it's tall. And you put the at least one frame out of the space, and we use a blower. I'm not sure she has enough honey. I don't see very much honey up here. So, okay, well, I'm gonna put this one back in the middle where it was. She's not, I'm melting.
That was a newer frame we put in.
So that's the student that helped to film it. And what's really cool about that video is we have bees at different places. So the ones he's holding here in this picture right here at the end, those are from what you call a top bar hive. So it's a horizontal hive and the bees build their honeycomb underneath. And the way they build their honeycomb is that I talked to you about honey and nectar, right? They have to eat over 20 pounds. That's like 2 big sacks of potatoes of nectar. They have to eat over 20 pounds of nectar just to sweat out 1 pound of beeswax. So what they do, just like the royal jelly and the way they convert it with special glands, they actually will eat all this nectar and they have special glands on the sides of their body, on their abdomen, where they then will actually secrete wax. And the wax comes out in tiny, tiny little flakes. And then they pass it from sister to sister and press it into the wonderful hexagons that we see, right? And the hexagon shape of the honeycombs is pretty special because it's one of the strongest shapes that we know of. It also can hold the most volume. So for honeybees in their hive, this wax comb that they build actually serves like their spinal column, right? And then they're able to rear their babies in it, store food. They can communicate on it by doing the waggle dance and vibrating. They actually are able to communicate on it. And so this wax structure actually serves as like their central nervous system. It's their communications board, their memory board. Everything that they come into contact with ends up in their honeycomb. And so as a beekeeper, we try and make sure that their honeycomb stays clean. And the way we can do that is, one, to ensure that they have good forage, they have good nutrition, right? But then when we harvest the older combs. And that way they get to keep the fresh ones. It's like changing the sheets in your bed, right? What you saw also in this video, and I'll just play it again, but I'm going to pause it here to show you a couple things from it. But so here we are, we're approaching the hive and we're using, this is a little special hive tool right down there. And then as we open it up, we use a smoker, and that's me pulling out honey. That's my coworker there, Paul, who's got the smoker. We use usually sage or other things to blow smoke. And here we are just harvesting honey. This is full ripe honey that's ready to harvest. And then we only take what's extra. So that's one of the main things as the beekeeper is we want to make sure that we don't take too much honey, right? Because if we take too much honey, then the bees don't have enough to survive. So first and foremost, we have to make sure that they have enough food. And I'm going to go ahead and come to the end, at least of the slideshow, so that we can answer some questions too. But when we plant flowers, that helps to create the nectars and the pollens, right? So it's really all about flower power. And a lot of these flowers are very medicinal. And so not only do they help to keep our pollinators healthy, but then in turn that keeps us healthy too, right? And so I'll talk to you here after I stop share so you can see my face. Now I can see you all. I couldn't see you while I'm sharing the screen.
We're out of time, sadly.
Oh, we're out of time. Oh my goodness. How did I lose track of time?
So we just want to say thank you to Melanie. Thank you to all of our students and teachers out there. And thank you for caring about our bee friends. We hope that you come and join many more of our events, and be sure to check out our National Geographic Education website for more details, including upcoming Explorer classrooms. Also, happy Native American Heritage Month. Please spend time this month learning more about the local Native American cultures where you live. As Melanie mentioned, these people have a rich history, a rich culture, and a strong presence in today's world. So you can look this up and find out about the Indigenous persons that live within your community. Also, a quick reminder, the time change is going to be happening next week in the United States. This is going to happen on November 7th. So if you live outside of the United States, be sure to check the time conversion so that you make our show on time. Everyone, have a great day. Stay curious, keep exploring. And if you're on screen with us, turn on your microphone and give Melanie a big buzzy thank you.